Humanity has always strived to reach places that seem to be out of said reach. Space is one of that places, and history taught us it is not an easy task at all to lead a successful space mission. The greatest achievement of humankind so far was putting a man on the surface of the moon. It was not an easy task, especially in 1960s, when computers had the computing power of a calculator, and the whole landing module was less powerful than today's smartphones that we are all used to in present days. When Apollo program was announced in 1961, with its main target to go to the moon, President J.F. Kennedy gave a speech so powerful that motivates the whole generations.
We choose to go to the moon. We choose to go to the moon. We choose to go to the moon in this decade and do the other thing, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win.
Well, today we've got computers and technology that allows us to simulate the moon mission on a laptop. In this video, we'd like to present you a cross-group effort that resulted in more than 15 crashed landings and over 20 hours of attempts. The process of designing a vehicle started with finding out how much delta V we should have to get to the moon. According to the map, to get from planet Kerbin to the moon, our rocket should ensure at least 6,250 meters per second of delta V. The rocket itself contains of 8 stages. There are 3 liquid-propelled side boosters that provide delta V of 1,209 meters per second, with a total burn time of 39 seconds and a specific impulse of 282 seconds. On top of that, there are 3 solid booster rockets providing the most of delta V, which are 7,025 meters per second. SRBs have the specific impulse of 290 seconds and generate thrust for 177 seconds. The central engine, which is REJ-10, utilizes liquid propellant, but it only provides 503 meters per second of delta V, as the specific impulse of this engine is only 70 seconds. The burn time is 238 seconds. On top of that comes the return crew capsule, moon orbit module, as well as the lander itself. The rocket uses gimbaling of the main engines as well as cold gas thrusters to ensure the correct trajectory of the rocket by a pitch maneuver. To allow efficient distribution of fuel, some fuel rails have been added across several fuel tanks. To add more stability, series of aerodynamic stabilizers have been added. Several iterations of the rocket have been built before the successful moon landing. Each iteration eliminated design mistakes and made the rocket more efficient. With each attempt, our little green friends named Jebediah and Bill travel farther and farther in a cold metal can. Once in the orbit, the Hoffman transfer was used to achieve the Moon's orbit. It wasn't easy to get it right, and several attempts have been made before successful transfer to the Moon's orbit. From there, the most important part was to actually land on the Moon's surface, and it turned out to be the most difficult task. The lander crashed several times, which resulted in explosions on the Moon's surface. If it was not a game, our natural satellite would get more craters. Speaking of, the Moon's surface certainly did not help. The landing module has landed on the crater's wall, and so it resulted in falling off the cliff in an unpredicted way. After a few more attempts, it finally became possible to land the ship on a flat surface. The total score achieved is really poor, lasting 1 day, 1 hour and roughly 48 minutes journey to the Moon turned out to be a one-way trip, as it became impossible to bring our little friends back home. Mission failed with a total score of 2000. Mission resulted in a correct landing and flag left on the surface, but unfortunately, this flag is the only thing kerbals are going to see before running out of oxygen.